Hi everybody, it's Miss Blaylock. Let me say hello. Hi, Miss Blaylock, giving you your first video. From me, at least. Hopefully you can read the words, and to make this video, I'm just going to show you how I go through the textbook with some of the problems. So Objective B is our next part in Chapter 1, and what I want to talk about first is the difference between y equals 2x plus 5 versus f of x equals 2x plus 5. This guy down here is called function notation, and there's some benefits to using function notation rather than just using the explicit equation. So if I had y equals 2x plus 5, and let's just say x equaled 4. So I say, okay, x equals 4. Most of you know I'm going to plug a 4 in for the x, so I'd have y equals 2 times 4 plus 5, so y equals 8 plus 5, so y equals 13. So that's all well and good, but now you say, okay, I have this equation. What was x again? Oh, x was 4, and if x was 4, y is 13. So you have sort of this process on the side, and you've got your equation, you had to plug it in, and everything's in a different location. If you use function notation, f of x equals 2x plus 5, your input goes in the parentheses. So I would write f of 4 equals, and then I would evaluate. So if 4 was x, it would be 2 times 4 plus 5, and that equals 13. So when I do all of the work, I know my input is 4, my output is 13. So I did the same work, but it's just kind of nice to have your input and your output all in one place. So that's one of the first things that we're going to discuss. This whole section is all from Chapter 1, and the example that I just did goes along with your textbook on page 149. So what I want to show you is, here I am on page 149, and down here there's a couple things I want to highlight to you. When I just did the function notation, I took the input and I put it into the parentheses. So if I had f of x equals x squared minus 3x, wherever I see an x, I would put in the value I want to use. So in your textbook, they put a little box to show you. And one of the other things it says, it's important to know f of x does not mean f times x. F of x is actually used most commonly because function starts with the letter f. So it could be a lowercase f and capital F. A lot of times you'll also see a lowercase g or a capital G, but any letter could be used. And frequently we're going to use x as our input, but sometimes t is our input. So your book even highlights the letter t is also common because in real world application it represents time. So you might see an x or t frequently. And although we think of y and f of x as interchangeable, the function notation is useful when we want to consider two or more functions of the same independent variable, or when we want to evaluate a function at more than one argument. So in the example I wrote down in the text on the slide was f of 4 equals 13. And if I wanted to do f of 1 and f of 2, I could list them all out, and I would see my outputs written down nice and neatly. Okay, the next thing I want to show you is example 2 from the textbook. And I'm sorry, example 3 from the textbook. So this says, given the function, right here, I would say this, given the function f of x equals 2x cubed minus 3x squared plus 6, find f of negative 1. What this means is, wherever you see an x, you're going to use negative 1 as your input, and then you're going to evaluate the function. Evaluate means you're going to plug something in and find out the answer. So my notation, this is going to be f of negative 1. That's equivalent to 2 times negative 1 cubed minus 3 times negative 1 squared plus 6. Just remember when you're doing this to follow your order of operations. So I would do negative 1 cubed, which is negative 1 times 2. So that's negative 2. And then here I would do my exponent again. Negative 1 squared is positive 1 times negative 3 is negative 3. And I have 6 left over. And now following the order of operations, it can just go straight across from left to right. Negative 2 minus 3 is negative 5 plus 6 is 1. So f of -1 equals 1. So take a minute, pause the video, and you try f of x. Oh, I'm sorry, don't try anything. I'm going to show you this one before I ask you to try. So f of x equals x squared minus 3x. This is another input. Instead of just having a number -1, we also could put an expression in. So x plus 1 is an expression. We could plug that in. So wherever you see x, we're going to plug in this whole thing, x plus 1. Going back to what your textbook did, if you think of it as like a little space holder, you're going to plug this expression into the space holder. So it's going to be f of x plus 1 is equal to, I'm going to put x plus 1 squared minus 3 times the quantity x plus 1. And now I just simplify. So x plus 1 squared, don't forget that you're going to have to expand this. And then mnemonic you're probably familiar with is FOIL, first, outside, inside, last. So you could rewrite this as x plus 1 times x plus 1, that first part, and it's still minus 3 times the quantity of x plus 1. And it's equivalent to my previous line, so I'm going to carry my equal sign down. So if I use FOIL, it's the first times the first, x squared, outside times the outside, plus x, inside times the inside, plus x, last times last, plus 1, minus, and I'm going to distribute right now, so -3 times x, so I'm going to go to the first term, and then the last term, -3x minus 3. Now I combine like terms, so I'm going to have x squared, we've got x, -3x, which is -x, and then I've got +1, -3, so minus 2. So f of x plus 1 equals x squared minus x minus 2. One last thing I want to point out about this example is your book shows you a correct way and an incorrect way, and they basically did everything that I just did. So this is on page 151. This is example 5. They've got the whole correct thing done like I did, and then the incorrect. So one of the things to point out, if you see f of the quantity x plus 1, that does not equal f of x plus f of 1. It's the quantity, that whole quantity is your input. So we would have f of x plus 1 does not equal, if we had simplified it the way they're showing you, that would have been incorrect. You need to plug in x plus 1 for your entire input. So there's a couple examples that we're going to save in the slides and do that in class. So practice 4 in class. You guys are going to be able to do that. If you want to try it now, you could. You would just have to pause the video right now and you can see it and ask questions when you get to class. The next part I want to show you is also done in your book. This is example 4, and I'm only going to do some pieces of it. So in your book, it has a graph, and on my paper here, it's a little bit dark, so I'm going to try to bring the picture up. Hopefully you can see it. Otherwise, you can turn to page 150 in your textbook, and you can see all the marks in here are red, and you're on the grids. So if we wanted to evaluate a function, and we had the graph of the function, we would use our input as the x value on the coordinate plane, and we're looking for our output, or f of the input is going to give you your output, and so that's really going to be your vertical y value. So if I wanted to find f of 0, what that means is my input is 0, so my independent variable x is 0. So here I am at 0, and in red is the function. If I want to know the output when x is 0, well, my function is right here. So what's my output? My output is 5. So f of 0 is 5 in this scenario. So right here, what is f of 0? It is 5. If you try to do f of 2, you're going to go over 2 because your x value, this is your x value, or your input. If that's 2, your output, well, it's right here, 2, 1. So that equals 1. If I go to f of 5, why don't you guys try it for a second? If you want to pause the video, you can. That equals 10. Okay, there's a couple more examples in your textbook if you want to try them out, or you also could just wait. There's another problem that we're going to do in class. So there's another function that's graphed, and we're going to figure out what the output is based on the given input. I want to show you a couple more things about function operations, and I'm going to be looking and going along with example 6b in your book. So earlier on one of the examples, we talked about the difference between f of x plus 1 versus f of x and f of 1, and your book gave you the incorrect example. So we did f of x squared minus 3x. We found f of the quantity x plus 1, but if it's broken down of f of x and f of 1, we would do something different. So here in this example, instead of using the letter f, we're going to use the letter h. Any letter can be used in function notation. And we're going to plug it, we're going to find h of x, and we're also going to find h of 1. We're going to find them independently, and in the end, we add them together. So what I want you to do is give this one a try if you're feeling up to it. And I'm just going to crank through the example. So what is h of x? H of x is right here. So if I'm going to find h of x plus h of 1, h of x is x squared plus 2x. What is h of 1? I'm going to jump right in and substitute. So I'm going to plug a 1 in for the x, 1 squared. I'm going to plug a 1 in for that x. Now I can simplify. So I have x squared plus 2x. 1 squared is 1, and 2 times 1 is 2. So 1 plus 2 is 3. So h of x plus h of 1 is x squared plus 2x plus 3. I would encourage you to try example 6, part A on page 151. And that's kind of like the example we did earlier. Okay, one other example. So now we're using g as our letter for the function. And if I wanted to find g of negative t, I have to plug negative t in wherever I see t. So if I do g of negative t, I'm going to have to worry about the exponents in order of operations. So I'm plugging negative a t in wherever I see a t. I'm going to put negative t in parentheses and square it. Minus, I'm going to plug in negative t wherever I see a t. So that changes things. So we've got negative t squared, which really means negative t times negative t, which is t positive t squared. And then negative t is plus t. So g of negative t is t squared plus t. And that was example 7a in your textbook. Moving on to example b. This is the quotient of f of 1 and f of 2. So again, you're going to use your inputs and your outputs and then simplify. So if I want to find f of 1 over f of 2, that is equivalent to 3. I'm going to plug 1 in for x plus 5. Now that's my numerator. I'm going to plug 2 in for f of x. So 3 times, for x in f of x. 3 times 2 plus 5. I would just follow my order of operations to simplify. 3 times 1 is 3, plus 5 is 8. 3 times 2 is 6, plus 5 is 11. So f of 1 divided by f of 2 is 8 over 11. There are a couple of examples that we're going to try in class, and that's practice 6. So this concludes the flipped video. I hope I was clear and that you can read it, and I will see you in class.